So when we look at this example, it doesn't appear that this integral fits any of the three forms that we have from our theorem on integrating involving inverse trig functions. But if we split this integral up into two separate integrals, then we will be able to integrate this using one of our formulas. So the first thing I'm doing is I'm separating this into two separate integrals by splitting this up into two fractions. Now, the first integral, looking on what's inside the square root, we have 4 minus x squared, and then in the numerator we only have an x. That suggests that we should be able to evaluate the first integral using a simple u sub from Calc 1, since the u that would show up in the denominator has an exponent of 2. That would suggest that when we take du, we'll drop down to an exponent of 1, meaning that I could pick up the x that's in the numerator, because I could solve for x dx and then be able to do my substitution. So this x dx that's in the numerator will be replaced by a negative 1/2 du. I'll go ahead and put the negative 1/2 on the outside of the integral and leave the du in the numerator. And then in the denominator, we simply have the square root of u from this 4 minus x squared that's in the denominator. So this first integral is simply negative 1/2 the integral of u to the negative 1/2 du. I'll integrate that by increasing my exponent by 1 and dividing by my new exponent and making sure to add my constant of integration, which leaves me with negative u to the 1/2 plus c, subbing back in what u is and replacing 1/2 with the square root, we have negative square root of 4 minus x squared plus c. And that takes care of our first integral. Then our second integral, the integral of 2 divided by the square root of 4 minus x squared, that's going to match number 1 from our theorem, where our a squared is equal to 4 and our u squared is simply x squared. So u is just x and du is simply dx. If a squared is equal to 4, then a must be equal to 2. So I can rewrite this integral. The 2 that's in the numerator, I can simply pull that out in front of the integral. The dx that's left in the numerator will be replaced with du. And then under the square root, we have 2 squared, just rewriting that to match this form, minus u squared. We'll keep the constant of 2 in the front. The theorem tells us that that integral is equal to arc sine of u divided by a plus c. In this case, our u was x, so we have arc sine of x divided by 2 plus c for our second integral. And then the last thing we'll do is we'll simply put these two together, because we have this part from our first integral and this part from our second integral. Combining those, we get the negative square root of 4 minus x squared plus 2 arc sine of x divided by 2 plus c. And that is our final answer.